Hey guys, and welcome back to your chemistry videos. Today we're going to talk about water, and then we're going to talk about electrolytes. So this are the first two sections in chapter 4. Now the first thing that we want to talk about is going to be water, and we're going to talk about why it's one of the most important substances on Earth. Now obviously it gives rise to life. It's the reason that we're able to be here and survive. Without it, we'd be in some serious trouble. But uh, we need to talk about why that's the case. What makes water so special? And we're just going to touch on this briefly, but it has to do with its shape over here. So if you look at this little diagram over here of water, we're going to get into what this particular shape does for it, and these little positive and negative charges, right? We're going to talk about why that makes water so special. The first thing it does is it allows water to be the universal solvent. These positive and negative charges allow it to dissolve a lot of things that most other substances do not have the ability to dissolve. But first, let's define a couple terms. First, aqueous means anything that is dissolved in water. So if you dissolve something in water, it's called an aqueous solution. And that is our next definition. Now, we call water a polar molecule because it has this unequal distribution of charge. And so we refer to these as delta positives and delta negatives. It's a Greek letter. And now when I say a positive charge and a negative charge, these aren't completely positive and negative. They're not like ions. It's not like when we have NaCl and this is a completely positive charge and this is a completely negative charge, the cation and the anion. These charges over here are partial, right? They're a partial positive charge and they're a partial negative charge. And that reason, we'll talk about it more later, but it's because of oxygen here. Oxygen likes electrons more. It wants to attract these electrons inside the bonds. So the electrons that form these chemical bonds right here, they're being pulled towards oxygen and away from hydrogen. And because it's pulling these electrons towards itself, well, electrons have a negative charge, and so it's going to give it a partial negative charge because it's holding on to these electrons more strongly than the hydrogen is. And since these hydrogens are losing the electrons, it causes it to have this partial positive charge on each end of the water. And these charges give water that unique ability to dissolve lots and lots of different compounds that we come across. And then this right here is the bond angle of water. We'll talk about this more later on in the year. So let's take a look here at this illustration. First off, though, we need to know the term hydration, and it's a pretty simple term. It just means the dissolution of a salt in water, or the dissolving of a salt in water. Now remember, we're not talking just about sodium chloride here. A salt is a cation and an anion that are joined together, an ionic compound typically. So anytime we dissolve one of those, it's called hydration. Now down here, this is just a general salt. Could be anything, could be sodium chloride, could be barium chloride, it could be anything. But you'll notice that in a salt, you have these negatively charged anions and you have these positively charged cations. And so when you drop it into water, water gets all excited because it has these partial positives and partial negative charges, and it zooms over to the salt and it latches on to the negative charge, which with the positive hydrogens, and the positive charges are latched onto, as you can see down here, by that partially negative oxygen. And so the water molecules zoom over here and zoom over until the salt is completely ripped apart and it ionizes. That's a word that you use a lot to describe what happens to salts or anything that gets dissolved in water. It ionizes, or it breaks apart into its ions. It breaks into the positive cations and the negative anions. That's a word that you should recognize and be able to use properly. So our salt here is ionizing in the water. Next thing we're going to talk about is going to be solute and solvent. Now, a solution is composed of these two things, right? A solution is made up of the solute and the solvent. The solute is the substance that's being dissolved, so that's typically your salt that you are putting into water, and the solvent is whatever does the dissolving. Usually it's liquid water. Now, for this chapter, we're going to be talking almost exclusively about water, but it doesn't always have to be water. Solvents can be anything that dissolve the solute. So it doesn't have to be water. It could be ethanol. It could be any other uh, compound or molecule that dissolves another one. And when we're talking about water here, water dissolves many ionic and many polar compounds. And that's again because of that partial positive and partial negative charge that water has, because of its shape and because of that oxygen pulling the electrons towards it. We also have this saying here, like dissolves like. And that means if you have a polar molecule, it's probably going to dissolve other polar molecules. Or if you have a polar molecule and an ionic molecule, they're pretty similar because they both have those positive, partial positive, and completely positive and negative charges. And so they're similar, and that means they'll dissolve each other, and that's how we give rise to this phrase here, like dissolves like. Now, something that's nonpolar and something that is polar, they're opposites. And so they aren't like each other, and they're not going to dissolve when they come in contact. So let's take a look here at this illustration as well. This particular molecule is not ionic. Notice there's no positive cation. There's nothing like NaCl, where you just have two different cations, or one cation and one anion. Here we've got a bigger molecule, and it's called polar covalent because of this part right up here. This is what makes the molecule polar. This oxygen, just like in water, pulls electrons towards it, and it does so, and it gives that oxygen that partial negative charge, that delta negative up there. And when it does that, it pulls the electrons away from this hydrogen, and now this hydrogen is a partial positive charge. So then if we go over here, right, and we take a look at this, if you were to dump some of this, and this is ethanol, by the way, this compound right here, this molecule would be ethanol, and when you put ethanol in water, because of this partial negative charge here and this partial positive charge, water with its partial negative charge is going to latch onto this hydrogen, and that's going to make ethanol very soluble in water. It's going to dissolve in water very well because of this polar part of the molecule right here, and then the polar part of the oxygen on the water molecule. They're going to attach and they dissolve very well. Okay, now let's get into our next part here, with which deals with electrolytes. And this guy named Arrhenius, he is the first person to identify the conductivity of solutions, and he proposes the idea of these ions. And he is from way back in the day, and so this idea of ions was pretty revolutionary at the time because they weren't really able to observe this very well. They couldn't see the ions. It was hard for them to detect, but he comes up with this idea, and then we decide to classify our electrolytes in two different ways, actually three different ways. We have strong electrolytes, and with strong electrolytes, they conduct current very efficiently. So if you were to run a light bulb through with an electrolyte as an intermediate, that light bulb would shine very brightly because it conducts electricity very well because it's a strong electrolyte. An example of this would be sodium chloride, or lots of ionic salts would be strong electrolytes. Weak electrolytes, they only conduct a small amount of current, so your bulb would light up, but it would not light up very much. And an example of this would be acetic acid, also known as vinegar. And our last classification here of electrolytes are going to be our non-electrolytes. And this is a solution where no current flows, right? The bulb would not light up no matter what. One example of this would be pure water, not tap water, right? Because tap water has different ions floating around in it when it comes out of our faucets, but pure distilled or deionized water, that would be a non-electrolyte because it doesn't have any ions floating around, so it cannot conduct electricity. And this here is just an illustration, and if I have one of these setups, I'm going to actually do this for you guys in class, but you can see here with a strong electrolyte, this bulb shines very brightly. With a weak electrolyte, the bulb is on, but just barely. You get a really faint dim glow. And then with a non-electrolyte over here on the right, you get nothing at all. The bulb is completely off because no electric current can be conducted through this non-electrolyte solution. All right, strong electrolytes. There's three different types of strong electrolytes so that you're able to identify them without actually having to test them with a light bulb or with some other piece of equipment. But let's first define that strong electrolyte. It's a molecule or a compound that dissociates completely so that every molecule becomes an ion. All right, so everything breaks up. Sodium chloride in water breaks up completely, so you have tons, thousands, millions, and millions of these little ions floating around. So it's a very strong electrolyte, conducts electricity very well. And so soluble salts are the first category of strong electrolytes. Any salt that dissolves well in water is going to produce positive and negative ions, and when they're hydrated, then they're mobile and we can produce an electric current very well through that solution. The other one that we're going to talk about here are strong acids. Now, we'll have to recognize these four strong acids down here, but when you put an acid in water, it produces H plus ions when it's dissolved. Strong acids dissolve completely, and so they produce millions and millions of H plus ions, and as a result, they can conduct electricity very well. But there's only a few weak acids, so we have to be able to recognize them so we know if they're a strong electrolyte or not. These are four of them. I believe there's two more that I'll add to the list at a later time, but for now these four will suffice. We have perchloric acid, nitric acid, hydrochloric acid, and sulfuric acid. And then the last type of strong electrolyte is the counterpart to a strong acid. It's going to be a strong base. And those are substances that produce OH ions when they are dissolved in water. And the only two that I'm going to require you to recognize right now are sodium hydroxide and potassium hydroxide, but there's plenty of other strong bases, and we'll talk about those at a later time. But notice over here, you put a strong base in water, you get tons and tons of OH ions and a bunch of Na plus ions, and as a result, you have a solution that conducts electricity very well. Now your weak electrolytes, those are substances that only partially ionize. And when they do ionize, it's usually only about 1 out of every 100 molecules that does ionize. So whereas a strong electrolyte is 99 or 100 out of 100, weak electrolytes, they don't ionize very much. But it is enough to conduct an electric current very slightly, right? It lights up our light bulb just a little bit. And our two classifications here are going to be our weak acids and our weak bases. And there's a bunch of these. We'll talk about how to recognize these later. But for now, you should just know that your weak acids, your weak bases, they are your weak electrolytes. And then your non-electrolytes, we're not going to have a slide for. Those are just any solution that have no ions in them. If there's no ions present, then they can't conduct an electric current. So that's all for this video. Hope you guys found it useful. Let me know if you have any questions in class, and I will see you guys next week. Thank you.